Hello. Oh, my webcam's not there. 1 second. There we go. That's looking pretty grey. That's looking a little bit better. Okay. Hello, everybody, and welcome to JavaScript with Joe. We are on day 15. We're now 3/5 of the way through this holiday-themed challenge. There's 14 other videos on this channel if you want to see them as well. But today we're going to be on day 15 of last year's Advent of Code challenge. And I'm going to be solving this on replit.com, so you can see my code when this is over. So if you're watching this later, you can see the answer that I've come up with there. What else? I guess if you don't know what Advent of Code is, it's a collection of 25 challenges with usually sort of a holiday theme. This year they're all sort of based on a submarine adventure for some reason. I can't really remember, but you can figure that out. But you can also see all the previous years as well. I'm not sure where you do it. I think if you just change it here, you can go back. So they've got literally like 10 years of challenges on here that are pretty cool. So we're going to work through them. They're normally quite difficult. They're sort of coding interview style, algorithm-based questions, but some of them you can get through without that kind of knowledge. I'm trying to solve them all in an hour, and I think we're at sort of like a third to sort of 50% pass rate there. They also all have 2 stages. So once you solve the first half, you'll get another half that will normally punish you for cutting any corners and stuff like that. But anyway, let's get started. So we'll be going for about 55 minutes now, hopefully getting halfway done around 1/2 past. But yeah, let's get into it. So day 15, you've almost reached the exit of the cave, but the walls are getting closer together. Your submarine can barely still fit, though the main problem is that the walls of the cave are covered in chittens. Ew. It's like a little shellfishy thing. It would be best not to bump into any. The cavern is large but has a very low ceiling, restricting your motion to 2 dimensions. The shape of the cavern resembles a square. A quick scan of the chitin density produces a map of a risk level throughout the cave. Your puzzle input, for example, and we've got a big example, we'll probably use this as our test case. So in that REPL that I've shared, you've got an input file and a little bit of JavaScript that will read that input file. Hello, Matt Uwe, welcome to the stream. You start in the top left position, your destination is the bottom right position, and you cannot move diagonally. The number at each position is its risk level. To determine the total risk of an entire path, add up the risk levels of each position you enter. That is, don't count the risk level of your starting position unless you enter it. Ooh, I'm about to sneeze. Unless you enter it, that is, yeah, leaving it adds no risk to your total. The goal is to find a path with the lowest risk. In this example, the path with the lowest risk is highlighted here. Okay, the total risk of this path is 40. The starting position is never entered, so its risk is not counted. What is the lowest total risk of any path? From the top left to the bottom right, here is my puzzle input. And it's a much, much bigger square. I'm just going to go blow my nose real quick, 1 second. Okay, apologies, it's a bit hay fevery at the moment. Right, this is a big square, so I'm quite scared. I imagine we're going to have to do something. I mean, it's basically a tree traversal, though we build the trees. I'm not sure if we can move. It doesn't say that we can only move right and down. Though it gives that example. Because it's a lot easier if we can only move right and down. But you know, if these were all ones up here and down here, that could form the best path, so we can't really make that assumption. I guess all we can do is not go back on ourselves. There's no point re-entering one we've already been in. Okay, let's see if we can replicate this at all anyway. So I've already got this stuff in here. So this is importing a package that manages files. So that allows us to read in this file. Then this will read in that file line by line and split it into an array. So you should have, if you're using this, an object that has those. And we can use that to sort of create the board. So I might write something that just prints the board real quick. So this is a function called printBoard with one parameter called board. And in here, I'm just going to do board for each row console.log row. So if I call that now print board on input, there we go. So we get the sort of format I'm expecting to see here. How are we going to mark? I guess we could replace whatever we've visited with an X or something just to mark the route through. They use nice bold numbers here, but we don't have that privilege. Board. So I guess we need something like start position equals, and let's say that's from the top, that would be from left for the X, from the top for the Y. And how can I actually access that? So maybe I'll do a, oops, let's replace set the board X will be, board Y will be the row it's in. Like that. So I can call replace XY on start position 0 for the X. Oh, yes, start position 1 for the Y, and the board is our inputs. Cannot set property undefined of undefined. Code set not allowed a tuple. Right, let's do a list instead of a set of brackets. There we go. So there should be an X in that top left position, but I haven't returned anything or done anything here. I need to return the board. Maybe let's make a copy of the board. Let board equal input. It's called chickens. I don't know, risk board. And then I can put that there, put that there, put that there. I should have an X. What's going on? Oh, because it's not a sort of writable array, it's a string. So this isn't really doing anything. So I need to map the board. So I need to input dot map for each row. We're gonna do row dot map. No, it's not rows though, is it? Oh, it is rows. Character. Actually, we're just going to replace each row with row dot split, and that should reduce it down to an array. Oh. So let's get rid of this for now. Oh no, my print doesn't work either. Why not? Riskboard is input.map. Input.map row.split. Hey, that's what I wrote. Is it this extra black bracket? I'm not actually returning anything there. There we go. So I could probably just write that, and then now my console log needs to sort of build a string. Let new row equal empty string for each row dot for each character new row plus equals character. I guess I'm going to let the new row be in here. Actually, no, let's leave it out there. We just need to define it, then we need to set it to be something empty, then we need to append to it, and then we need to push that into our row. What am I doing with these new rows? Oh, printing them out. That's it. But okay. I feel like I've had to write that function every week. So printing board is working. Replacing board is potentially not working. It is working. Okay. And it's not just that we want to replace the board. We kind of want to store what we're entering, though we're not actually entering that piece, so we can deal with that later. Right, so from here I need to get my options. So get options. So from this first position 0, 0, I can only move right down. So I guess I want to check all other positions and see if they're going up or down. So I need an X and a Y. The board, I can just access the global board, so that should be okay. Yeah, that should be it. And I guess here I want to return, I could choose to return something like, you know, a list of options like L, R, well, maybe let's call it something like north, south, if that makes sense. So see here we can only go right or down, so let's just build just that functionality for now. In fact, that'll let us pass the whole first task if we just do left and down. So if board, well, risk board, so let's do get east, let's call it right. get right, get down, if risk board, X. Let's just try replacing something that isn't just the first one. Let's see if I can set the start position to be there. So X1, yeah, that's fine. Right, so if risk board X, so we're going to the right, so it's X plus 1 Y is defined, or will that just error? Risk board so we get a type error, cannot read property 1 of undefined. So do you need to do if? I check if this is defined first. So if that is defined, then we should just be able to access it. So let's just call get options with our start position. So right is 1, I guess that's true, but it will be. We also need another if to get the downs, get down. Cool, so let's close this up for a bit more space. And really I want to log out whether there's valid options, but let's just try a few others for now. So there we go, we've got no valid options if we're in the bottom right corner, which means that we finished if there's no valid options, so that's good. So yeah, that looks okay. Let's just pick another one just to see that we're not always just returning 1 and 1. There we go, down is 8, which isn't true, and right is 1, which isn't true, so I've got them inverted there. So to the right, this is 8. That is Y, because it's not really Y. They're not X and Y. They're more like row and character. Maybe that would be an easier way to work through this anyway. Right, back to the first position. So we are replacing, I guess let's call it current position. And then let's replace all these. So we'll print our start board. Get our options. And now we kind of need to build a tree, right? We could naively, like always, follow the best option or the lowest option and just see what that gives us. That probably won't give us the correct answer. So that might be an easier start than jumping straight to iterating something. So yeah, how do we do that? We need to return something here, I suppose. So options equal I guess we'll do nothing, and I'll just do options dot append down, let's do down, and options append right. And then we just need to return those options. Ooh, that's Python, sorry. Push in JavaScript. And so now we should have the options here. Options. And there we go. So we can go down or right. Though we probably need to know whether they're... Probably need the number as well. So let's push, not just right and down in there. Let's push something like direction down risk, and that will be this. And let's tidy that up. Same for the other one, except that's down, that's row, that's one. And then we don't need that anymore, we don't need that anymore. Let's still log out, yes. I guess that gives us both options for now. No, we won't. I was going to say we could just pick the best option here and return that. I'll write it. Const get best option takes the options, and it's going to say if I guess options. We're not always going to have both options, so if options.length is 2, then if options 0 dot value risk is greater than options 1 dot risk, then return options 1 dot direction, else return options 0 dot direction. And then if it doesn't have 2, do else if options.length equals 1, then there's only one option, so we return options 0 dot direction, else there's no options, so we probably need to, I don't know, just end it. Right, so now we can call let options equal, let's keep that actually, let options equal this, pop that there, and then we can say console.log best option, best option, comma get best option options. Can I access options before initialization? options. Where's it complaining about? Line 27. Cool. So we've got best option down, which doesn't, I mean, it's going to matter, but it doesn't really matter for the way we're trying to iterate over everything. Let's change this again to something in the middle, just so we can actually see if we're getting the best option. So down has a risk of 1, right has a risk of 8, so it's picked down. That looks all right to me. So best option equal this, this, and then we need to move. So const move equals current position, direction. Let's make that return. We need a little bit more. If direction equals down, oops. Direction is equal to down, then return current position. Current position x plus 1. Oh, it's not stored like that, is it? Current position 0 plus 1, and current position. The second one, else if direction equals right, return that, but it is this one that is plus 1. And then let's do new position equal move current position, and best option. Console.log new position. Oh, do I not return anything and move? No, I return. It's my direction, not what I think it is. Weird. Move current position, best option, move. Position and direction. So I have got down, got my numbers. So how could this be defined? Oh, undefined, because it's trying to access that item instead of just returning this array, that's why. So this should just be an array. And this should just be an array. Oh. Why is it returning a one-dimensional array? This should be a comma separated, just like that, I think. There we go, 1, 0. So we've moved down, we're in row 2, 1, 0, we're entering something. So maybe let's up here have like an entering, like a risks so far or something. Let risks taken equals an empty list. And as we enter that option, let's do so as we're moving, it's probably in the move we should do it. We're going to do risks taken dot push. Oh, I don't have my direction anymore. How did I get that? My best option. I guess I can get the number from here, so I can say, so I can go if direction is down, or can I use, I guess I can do this in here, and that needs to be risk board. It needs to be these, but now it does need to be in brackets, and this one does need to be in brackets. Same for the other one, but that needs to be without a +1. It needs to be +1. Right, let's log our risks taken. Yeah, that looks right. Then in there we also need to do this replace x, y. So that needs to be our current position 0 +1, current position 1, and the board, risks board, and then the same in the below. This needs some work, I think. 1 + 1, 0 + 1. Oh, should that be inside it? Risk board is not defined because it's just risk board. Where was I even writing that? Risk board here. There we go. So we should be able to print the board again now. There we go. Now it says it moved down, but it has drawn the risk to the side. So if I got those the wrong way around again, this is going to be quite a big problem if I keep doing this. So replace x, y. When we're going down, it's doing the next row. Right, I did reverse those at the start for some reason, but maybe my model has changed now. Right, so now we just need to do this until our get best option is is not end. So while let's do let best option equal start, while best option is not equal to end, put all this in there. Maybe I don't need that extra print board at the end now. And what else do I need to do? Current position can't always be set to 0, 0. So that needs to be updated at some point. So when we move, what did I call move? New position. This needs to be current position. But we can still log it as new position. Will that work? No. Cannot access current position before initialization. Online 84. So this can't access it. Does it need to be a variable? Why hasn't that been defined? Is this being defined twice? Oh, it is defined twice. That's why I was complaining, because it was defined down there. Right. Well, look, it did get all the way to the end, and then our functions all started breaking, so it's not too surprising. When it gets to the end, there is no new position. There's no move to make. So if best option not equal to end, then we'll do this. And then we can print one last board just outside the loop. Oh, I guess I could print it in here. Oh, it's going forever. So when it does equal end, it's not updating the... Oh no, that should be okay. Why is it going forever? Go to ever until the best option is equal to end. Here, best option is equal to end. But we're not moving on, so it's still doing that last calculation from here, or whatever choice it had to make before it got there is probably what it keeps doing. I thought we had more console logs in this. Where's it gone? So let's get rid of all that. Maybe there's something else I can do to work around it. So what's actually breaking? Undefined. Can't read 0 of undefined on line 85. So it's going back here, so it's running again, even though the best option is, well, it should be equal to the end. In fact, it is equal to the end. Now, why are there loads of X's in my risks taken? Seems a bit off. Yeah, the X's are being drawn at the wrong time, it looks like. So the X is being drawn whenever it's moving to the right, but whenever it moves down, it's getting the right number. So that's a good clue. So when we move, something in here is not right. So what have we got? Risk taken is what is that? Yeah, that's okay. Current position 0. And then what's happening with the new position at the end? It's getting to here again. It's trying to replace something, but it shouldn't be, because best option is end. Our best option is not equal to end. Sure, I just wrote this, but I'll whack it back in there. This is why it ran forever, yes, I remember now. So something, but it's like the while loop isn't finishing though. Seeing there, best option is equal to end, while best option is not equal to end. Because I'm redefining best option here, it was the same issue we saw before. There we go. Right. Now we have our issue of the X positions, which I'm going to check if they're related again to this. great. The bizarre messages are coming again. Cool. So something is going wrong here, but only when we take the down option, our positions are wrong. So these are not quite right. So let's log out. In down console.log row current position 0 console.log char ports 1. It ended. Was it ending always? Okay. Maybe that wasn't a problem. Right, so, oh no, it was the X's, that's what we were looking at. It's not that it didn't end. Hey. Right. What have we got here? So 8, 9. We should be replacing the XY in the old position, not the new position. But we're moving. So are we moving after we've updated the position? No, probably not. So these should match everything else. I guess when somebody's moving down, no, the down is working. It's the right that's not working. When somebody's moving right, have I got this? If I've got this wrong, then there'll always be one to the left of the position I'm looking at. So down right 1. In down, in right. 4, 3, new positions 3. Oh, I should be pushing the. It's because I'm pushing the risk taken after I've already done the replacement. So it is the right position, which makes sense. Right, so we have a route through. Console.log risk taken. What are we looking for? The sum of the total risk. What is the lowest total risk of any path? So total risk, then risks taken dot reduce. I'm not sure if I can remember how to do this. A plus current A or something like that. How do I do a reduce? Reduce previous value current. Current previous plus current, and then an initial value, which I don't need. Okay. think if I set the previous to 0, then that'll force them to be numbers, maybe. No. If I convert this to a number, will it make them all be numbers? If I make this a number, will it make them all be numbers? Total risk 44. Okay, cool. So what we've basically done there is we've just implemented a really, really naive algorithm that just assumes whatever it looks at, if it goes down or right, it'll be best. And we've even made it prioritize going down over going right. So there are places like here where that might have given us better options, even though they're equal on one step. So we have sort of kind of like a model that only thinks one step ahead of where it should do, whereas what we probably would do next if we had more time and it was easier to do is sort of build all the possible trees we could do. So we could build up, a big list of potential risks taken and just traverse everything and not even care about which one's better or worse. I just thought this would be a nice way to get started and then refactor, but I did write some 100 lines of code there. Hello, Timothy Cameron. Hello, Paul Dexter. Thank you for the thumbs up. We're just about finished now anyway. We've got about 5 minutes left. I don't think I'm going to be able to refactor all that into trees. So I can submit 44. That's not going to work. Let's also see if we get punished on the big input, because that might take a really long time. Certainly will with all those logs. And the printing of the grid is so big that I can't even really print out the root. Oh no, there we go. Yeah, I can send you that gist. Sure. This is just a gist I made to make branded seaborn plots if you're interested in that. Hey, we did get an answer though, 762. We got a root. Oh wow, you can even see it, look. So you can see it taking what it thinks is the best route all the way through there. It's quite interesting. So we did get an answer of 762. I highly doubt that's going to be correct because we weren't even correct in the sort of the simplest case. Yeah, too high. Not too surprising there. But I'm amazed it did finish in time. So I guess, we just did sort of a somewhat linear search instead of spanning all the different trees. But I will set this back to be the template input just so that it runs if anyone does want to look at it later. But yeah, next steps, I suggest you actually try and explore the whole tree. But yeah, I'll leave it there. Thank you very much, everybody. Bye bye.